The Challenger space shuttle disaster was an engineering failure that took place on the date of January 28, 1986, and it launched from Cape Canaveral, Florida. The Challenger space shuttle collapsed within 73 seconds of the flight and was responsible for the death of 7 crew members on board. This was the first ever American space shuttle accident that was fatal. The goal of this mission was to launch the second tracking and data relay satellite known as the TDRS-B. This space shuttle also carried the Spartan Halley spacecraft, which was a small satellite that was to be released by the Challenger space shuttle and picked up a couple of days later after observing and gathering information of Halley's comet. The cause of this disaster was a mix of a lot of different variables. That first being that the launch was being postponed for several days, partly because of the delays of the 61C Columbia back to the ground. Before the night of the launch, most of the state of Florida experienced a cold wave that would be so cold it would create a thick layer of ice on the launch pad. On the launch day, the space shuttle was delayed for liftoff until 11:38 a.m. because the conditions just came out of maximum aerodynamic pressure. Because of the severe coldness that morning, this reduced the resiliency of 2 rubber O-rings within the ship that sealed the joint between the 2 lower segments of the right-hand solid rocket booster. This would be the main cause of the explosion. The people that were involved in this incident were a group of different people with occupations such as being a teacher, commander, pilot, mission specialist, and an aircraft engineer. These members' names were Krista McAuliffe, Francis Scobie, Michael Smith, Ellison Onizuka, Judith Resnick, Ronald McNair, and Gregory Jarvis. After the Rogers Commission was finished with the investigation of the Challenger, they reported to President Ronald Reagan that the groups at fault were NASA as a whole, specifically the Marshall Space Flight Center and contractor Morton Thiokol Incorporated, all due to poor engineering and management.
The major stakeholders involved in the Challenger incident include the astronauts, NASA as an organization, the individual engineers, and the federal government. The obvious party with the most on the line was the astronauts. They were the ones putting their life in jeopardy that day in 1986. I would wager that they were mostly motivated by their duty as astronauts to complete the given mission. On a less professional level, the human instinct to survive plays a large role in the mindset of the men and women on the spacecraft. It's no secret that being an astronaut is an honorable profession, but it'd be hard to imagine that they wouldn't have also been motivated by fame and glory to some degree. NASA as an organization was at the time being budgeted $16 billion inflation adjusted, which was just half of the sum acquired during the height of the space race, and they were searching for new projects to grab attention. In 1986, NASA was unveiling its Space Flight Participant Program to do just that. The program would put a foot in the door for private citizens to fly on space shuttle missions and allot for such occasions 2 to 3 times per year. The program was to begin by sending teacher Krista McAuliffe on a 6-day mission aboard the Challenger. On the day of the launch, NASA as an organization was motivated by the desire for increased funding and for the survival of their newest space program. The engineers involved in the design and development of the spacecraft were motivated almost entirely by professionalism and pride. As engineers, their main job was to identify a problem, find a cost-effective solution, test the solution, and manufacture the solution. In the case of the Challenger, Morton Thiokol Incorporated was behind the development and assembly of the boosters. The engineers at Morton Thiokol were simply doing their job as best they could. Their major oversight was in not preparing for low temperatures and its effect on the resilience of the O-ring seals in the right-hand rocket booster. With their reputation on the line, they made the design decision that they thought was best with the time they had. The management in charge of the engineering team, however, was more motivated with the deadline from NASA than sorting out potential issues with the booster design. Lastly, the federal government. As the sole benefactor to NASA, the government had a lot to lose regarding the Challenger mission. A failure would shake taxpayer trust in government spending and cost a fortune in investigation costs.
The ethical issues involved in the engineering design that led to the Challenger space shuttle disaster were that many NASA engineers and managers had been aware for approximately 9 years before the disaster that the O-rings that failed had a potentially catastrophic flaw. During this time, there could have been room for a new design or development of the issue, but the problem was ignored. This failure was due to the deformation of the O-ring seals, which were intended to prevent hot gases from leaking through the joint during the burn of the propulsion engine. This would lead to the separation of the right-hand solid rocket motor's attachment and a failed structural integrity of the externally located tank. The aerodynamic forces from the flight would then soon break up the rocket. Another ethical issue that could be included in this Challenger space shuttle disaster was that there was no escape system that was implemented in the design, which was previously invented by Maxime Faget in 1958. The ethical issues involved in management and response of engineers to management that led to the disaster were, despite the concerns of the frontline engineers who predicted this awful catastrophe, management from NASA and its contractor decided to move on with the design and ignored dangerous warnings. There was also a lack of communication that led to an unclear understanding of what was going on with the O-rings with higher-up decision makers of the Challenger project. The Rogers Commission concluded that the failure of the space shuttle was due to an ethical decision failure within NASA that included faulty communication and the lack of checks and balances within the corporation. As a result of the ethical and professional shortcomings that were described above, the subsequent outcome that impacted the environment was that the space shuttle remains after the explosion had to be cleaned up from where all the remains landed. Some of the other environmental impacts of this would include the extra amount of CO2 released after the explosion that was deposited into the Earth's atmosphere. For a usual rocket launch, there is about 50 to 75 tons of carbon dioxide that are deposited into the Earth's atmosphere per passenger. And with 7 members on board, this would equal 350 to 525 tons of CO2. With an explosion using its full fuel capacity, this would even be more CO2 than it is listed here. These issues can impact the Earth as a phenomenon known as climate change, where greenhouse gases trap heat into the atmosphere of the Earth and affect global temperature, which in result will affect the environment.
In 1972, the Space Shuttle program was approved by President Nixon in an attempt to establish the National Space Transportation System and provide routine economical access to space. A part of this goal was to begin sending private citizens on board Space Shuttle missions and establish space travel as a safe form of future transportation. The Challenger disaster proved just how hazardous this task would be. In light of the Challenger incident, President Reagan established the Rogers Commission in order to investigate the Challenger failure and make recommendations for the recovery of the space transportation system. From this commission, the National Research Council appointed an audit panel called the Shuttle Criticality Review and Hazard Analysis Audit Committee, which is now in charge of providing risk assessment and verification for the adequacy of the project in question. This committee reports straight to the administrator of NASA and wields absolute authority over the continuation of shuttle missions. Another policy review brought up in the Rogers Commission is the Shuttle Processing Contractors Policy, which authorizes a non-NASA technician to inspect and approve them and their employees' work. This can be problematic due to the inspection standards being hard to regulate with multiple entities conducting these verifications. Other than some minor shuttle payload regulations, there wasn't much of a global impact. The only change that could be considered global would be President Reagan's decision to ban commercial communication satellites from the payloads of U.S. space shuttles, which could be considered global because they would occupy space above other countries. The economic impact of the Challenger disaster was by far the most prominent while researching. The unadjusted NASA budget prior to the Challenger incident was $7.8 billion, and post-Challenger it increased to $10.9 billion. That's almost a 40% increase in funding. According to the Congressional Budget Office, the first step to recovering from the incident was to allocate more money for NASA over the next few years. It was highlighted by the Budget Office that a request was put in to raise NASA budgeting specifically in research and development by $503 million just in 1987 alone. Putting the NASA rebuilding effort aside, much more money had to be coughed up by the federal government to put out fires caused by the incident. It's estimated that initial reconstitution cost totaled $240.5 million in 1986 and $245 million in 1987. This first class of cost included the expenses of the investigation, system modification, and the replacement of lost equipment. Even after the initial installments from the first 2 years, an overflow of $205 million had to be deferred to future years. In order to free up assets to pay for the recovery, net operational costs at NASA decreased by $98 million in 1986 and $130 million in 1987 due to a decrease in spaceflight operations after the accident.
The societal impact of the Challenger disaster was felt immediately, as the launch drew the attention of millions of people across the United States who wanted to watch the 7 astronauts leave the atmosphere. As one of those astronauts was Krista McAuliffe, who was a teacher from New Hampshire and would become the first civilian to fly to space. However, with the launch having live spectators at the Kennedy Space Center as well as millions watching live from home, its failure and explosion would be widely witnessed and immediately impact society across the country. Not only did this cause immediate heartbreak and shock across the United States, but it would continue to have an impact on society over the following days, months, and even years, drawing more attention from the public and media. The situation received extensive media coverage in the days following the disaster and would ultimately have a negative impact on the way that many viewed NASA and spaceflight, where it would have before been positive and exciting. The Challenger disaster would lead to many being hesitant about shuttle missions going forward and set back public support for future endeavors in space exploration. Starting with the fundamental canons of the Code of Ethics for Engineers, the one that NASA and its contractors involved in the Challenger space shuttle violated the most was number 1, hold paramount the safety, health, and welfare of the public. The Challenger project as a whole saw management prioritizing a low budget and tight deadline with little delays, even despite the concerns raised by engineers about component safety and requests for delays. More specifically, looking at the rules of practice underneath Canon 1, it can be seen how the Challenger project was in opposition with Rule A. If engineers' judgment is overruled under circumstances that endanger life or property, they shall notify their employer or client and such other authority as may be appropriate. Engineers had raised multiple concerns over the reliability and safety of the O-rings that were set to be used in the Challenger and had requested a delay in the project to rectify the issue. But the project's upper management overruled these concerns due to the tight deadline and budget the project was on. However, even despite these concerns from the engineers being ignored, the engineers and other parties involved did not notify the highest management at NASA or even the United States government that oversees this space program. This could be due to this being a normal occurrence within NASA's projects with the tight deadlines and overworked personnel, even with various other issues being investigated by the government. It could have also been derived from the engineers' fear of jeopardizing their careers if they were to speak up. In addition to Rule A, it can also be seen how the project would be in opposition to the related Rule F. Engineers having knowledge of any alleged violation of this code shall report thereon to appropriate professional bodies and, when relevant, also to public authorities, and cooperate with the proper authorities in furnishing such information or assistance as may be required. Since upper management's suppression of the involved engineers' concern would have violated Rule A, it would have been advised for the engineers and any parties involved to alert the proper authorities about the issue and provide all necessary information to investigate the case, which did not take place. As a result, the concerns were never acknowledged, and the Challenger project continued on its schedule with minor delays until the day of launch, where the O-rings experienced a failure due to unforeseen cold temperatures that morning. In regards to the professional obligations listed in the Code of Ethics for Engineers, it can be seen how the project's engineers and management would be in opposition to Obligation 1B. Engineers shall advise their clients or employers when they believe a project will not be successful. As discussed before with Rule A and F, the engineers and engineering managers involved failed to notify management at NASA above the project and the United States government about the O-ring issues and concerns at hand, which would end up costing the 7 astronauts of the Challenger their lives while also causing destruction to the shuttle, environmental impacts due to explosion and debris, and to the societal impact of the public watching the tragedy in real time. Given the fundamental canons, rules of practice, and professional obligations of the Code of Ethics for Engineers discussed before that the Challenger project would have been in opposition with, it would have been the responsibility of the engineers and engineering managers involved to fully investigate and conclude that the O-rings were unsafe and a liability to the project's stability and safety, to appeal their concerns to upper management, and, if no action was taken by the project's upper management, to report the issue to the highest management at NASA, the appropriate overseeing United States government parties, and/or the proper authorities. In this situation, the project's poor leadership and improper procedure could have been brought to light and rectified, which would have led to the Challenger launch being delayed and the O-ring issues corrected. However, the correct course of action by both engineering and management would have been to never look or overlook the engineers' concerns in the first place, making the decision to delay the launch until the issue could be properly investigated and resolved. Only once the O-ring issue was properly addressed and approved by a licensed engineer, and potentially an outside entity to ensure safety and no bias, should the project then have proceeded with a new appropriate launch date. The ultimate priority of the project should have been the safety and reliability of the shuttle and its passengers, but instead it was completing the project and on time and within budget, leading to the issues that result in its disaster.